Welcome you to my another video about tools. This video is like a follow-up. Hioki has recently added better functionality to their Gennect cross application. So in this video we'll talk about THD and how you can measure THD with $400 equipment. First, huge thanks to testovací technika company for lending me these precious Hioki multimeters for review. I could actually keep this DT4261 with Bluetooth module. You may remember it from my previous review on this channel. I don't record many stuff here because the channel isn't growing at all. So I rather focus on my main Czech channel with 20,500 subs. But if something would have impact worldwide, I also record it here. And here we are. First we explain what is THD, what is FFT, and then we'll move to measurements, what problems does THD cause and how to fight against it. FFT, or fast Fourier transform, is a method how you can take a signal and decompose it to its harmonic parts. Why harmonic parts? Harmonic or sine is the most natural function and the base function that we meet everywhere. If something oscillates naturally, it does so mostly very close to sine. If a generator generates electricity, it's again sinusoidal. Sine is also the most durable function. We can integrate or derivate it and we still get the same function, only shift it a little when it comes to its time. Any signal we pass through, let's say, low pass filter may get distorted. Only sine never gets distorted. You can only have lower amplitude. Why so? Any properties of any components like chokes or capacitors refer to harmonic frequencies, sine frequencies. If we don't know how will our component behave with different function from harmonic, we must decompose the function to harmonic parts. This is done by FFT. Any signal can be decomposed to harmonics. Any. We can then isolate the separate harmonics and determine how well each of them behave in this component. So let's go to this webpage JSM1 to see the composition and decomposition. Here, if we sum up these two, we get the wave above. So if the major frequency, this one, would be 1 Hz, then this one would be 3 Hz with significantly lower amplitude. We can then add 5 Hz, 7 Hz, 9 Hz, 11 Hz and all the odd harmonics with lower and lower amplitude. See how the result, the sum of all of them, becomes square. So, based on this animation, we can say that our square wave would consist of odd multiplies of major frequency, or commonly called harmonics, and their amplitude gets lower and lower. We usually need like maximum of 15 harmonics to have a nice view of our signal. If we would filter out the higher harmonics, then the resulting square would become or wrinkly with overshoots, and if we filter out more hastily, then it becomes something like this. So this is the composition of square signal if we decompose it to harmonics. Now, what is THD? THD tells you how ugly your sine wave is. THD is the sum of all your higher harmonics amplitudes divided by the amplitude of our fundamental first harmonic. In practice, we have our switching mode power supplies, which are currently working at approximately 200 watts. We have variable frequency drives, or just almost every device, and their input current mostly isn't nowhere near sinusoidal. For example, DC power supplies only take current when the sine wave of the voltage is in its peaks. So it only takes current in this area and in this area. That's all. For the rest of the time, it's like for the rest of the time there is zero current, peak, zero current, peak. This is how your power supplies consume amperes. it's nowhere near sinusoidal. If you had resistive load like bulb or room heater, then the current will be the same, perfectly same as this voltage sign. If you have enough of these supplies, they actually can make the voltage uglier, because if they only take huge current spikes in these areas and in these areas, then they tend to flatten the voltage, because, well, they only load it in these areas, so the voltage always goes down. It's like if you put something under heavy load, its voltage drops. You know that when you are starting a car, for example. The distortion will actually come closer to square, so that's why we were referring to square wave so much. Higher distortion will cause problems. For example, my FSP UPS, twin battery UPS, is constantly monitoring network, and if someone uses hairdryer with thyristor regulation, well, the UPS actually triggers. I have my doubts that the hairdryer would pass regulations regarding ME here. The problems with THD can become more serious in factories. For example, modern and intelligent production lines, they usually have power monitoring, and if it senses too high THD or transient or longer undervoltage for like 5 periods, then the production line may shut down. This shutdown scenario only halts the production, but there are also some, let's say, catastrophic scenarios. I have actually encountered them myself, not witnessed, just I was there when we were fixing them. Factories must have power factor correction. These are huge cabinets with capacitors that get connected to the network through contactors, and these contactors are controlled by power factor regulator. Regulating power factor is a must because it lowers the apparent power consumption of a factory by even 30% down if the factory is full of motors or transformers and such. So it really makes sense, and it's actually mandatory here in Czech Republic. These capacitors that are used in power factor correction are just like classic electrolytics, but they are bipolar. They are similar to caps we know, and they, just like any capacitor, their impedance is heavily dependent on frequency. Their impedance, or something like resistance, it gets lower for higher frequencies. So the higher the frequency, the higher the passing current, because the lower the resistance it represents to the signal. High THD has higher harmonics in it, remember? So if a network has like 5% THD, it may run into severe problems with compensation capacitors. For example, a classic 20 kW cap takes approximately 30 amps, 32, something like this, in every phase. But with 5% THD, the current can climb by half, even by half, up to 45 amperes. This causes the capacitors to be heavily overloaded, and to compare it, overvoltage is like nothing compared to THD overloading. If you have overvoltage, if for example you have 400 volts rated capacitors, you are feeding them with 410, 420, it's like nothing compared to huge THD, like 5% or so. So overloaded caps, if they are good quality, they just get hot, they inflate, and as they inflate, they actually emergency disconnect themselves from the network. However, if the capacitor is cheaper or it experiences very high THD, it can even explode. I have seen many exploded caps, and sometimes they also trigger secondary explosions from these neighboring capacitors, because they too can be at the edge of exploding themselves. Well, capacitors are of course made of aluminum, so they may shoot the aluminum parts all over the cabinets and even land on main bus bars, causing that short circuit of course, and melting the bus bars and causing fire sometimes. So THD is dangerous. We must monitor it from time to time, and if it gets hot, we must take action. But how to determine the THD? Well, power factor regulators sometimes can do that, like these Czech novel regulators, but they are specialized devices, they are expensive, and they only measure in one phase. A panel mount power analyzers, you say? Well, good one. Today you can get one for like $400, maybe, if you want power analyzer with THD measurement. But what if I want to determine the cause of THD? If is it this production line, or is it this production line, or is it this device? Well, power analyzers aren't portable, so I need something to be used in the field. Portable data logging scopes. Well, they are known for this. They can data log and they can remember transients, few periods of under voltage. They can also constantly monitor THD. But how about the price? Well, around $400. Yes, it's 10 times more. It's like $4,000 approximately for these. So I guess you won't be spending 4K just to probe around a factory sometimes. Well, yes, you can order a company to measure it. We also do this service, and we usually leave the meter clamped for like a week or so, and the money is very attractive compared to if you had to buy the device yourself. But still, this isn't flexible. This is like the final measurement before countermeasures are applied. Like if you really want to project a solution, but not something to be used in the field. So how can I possibly probe around in the field to determine whether that may be worth my attention or whether it's absolutely okay and I can forget about it? I need something quick, portable, brisk, and not that expensive, so the factory wouldn't have to sell a forklift for it. Well, Hioki does that. These new generations of Hioki multimeters, they have so advanced ADC that they can perform FFT with astoundingly high accuracy, actually fully compatible with industrial solutions. Hioki DT4261, being $400 multimeter, is surely great for your lab. It's quick, convenient, it can data log and everything else. But when things get serious and lines begins to halt, you can grab it, bring it to distribution room, and use it as your portable analyzer. Hioki can measure THD for both voltage and for current. You can also use current clamp. I have this Hantec one here, so you can see what it looks like. They are usually with BNC connector, or you can use adapter for bananas. These current clamps are made by many manufacturers, and sometimes they are even compatible when it comes to signals. They usually output like 1 millivolt per 1 amp or so. Some of them are even adjustable. Well, if you don't want to use external clamp, it's not that convenient for you, you can buy clamp meter just like this one. But sometimes having two devices, well, it's on you. Having two devices may be convenient to you, or you just say you don't use the clamp function that much, so you would be good with just multimeter and external clamp. It's on you. These clamp meters, this Hioki CM4141-50, it can do up to 2 kiloamps, I believe. Yeah, 2000 amperes. That's hell of a current, I must say. So now I'm feeding the Hioki with a sine wave of amplitude 15 volts. It's clear sine wave, and we can see in the general measurement it's like this in the app. Now we can go to waveform/FFT, select this multimeter, and now we can see it's perfect sine. It's from my function generator, and the only frequency there is the fundamental 50 Hz. Now I can feed it with, for example, square wave. Oh, it's over. Well, let's decrease the amplitude so we have the same. Now we have square wave, and here you can see the square wave has this FFT. If we wanted to see it more precisely, then the recently added functionality is this harmonic analysis. I can go in this menu, the meter goes in HA, and here I can see all the components of the FFT of the inputting signal. Here we can see the graph. Here we can see the values of every voltage. I can hold it, and now I can list through all of them, all of the components. You can see these are only the odd harmonics for the square wave. So I unhold it. There is this one bug I would like to have fixed, and that's when I list it and it updates, then it sometimes jumps to the top. Strange. Connect. Yeah. So if I list through it, then it sometimes jumps up. You can see it jumps up. If I feed it with sine, then there is only the fundamental frequency and nothing else. And we can see the frequency THD has gone to 0.05, that's like nothing, and THD for RMS voltage value is like 0.05, that's also nothing. So you can see here we are feeding with plain sine wave. Now I switch to the square, and we can see the harmonic analysis, and the THD of the RMS value is 49.94%. That's that's so high value. If you were feeding this signal to your capacitor, then it would instantly explode. Now let's change to, for example, a trapezoid. That should be slightly better. CMOS adjustable DC ramp. Well, this is, oh, it's way worse. Look at this. This is ramp. I can go back. Waveform. So you can see the ramp. THD 80%. It's nasty. Negative ramp. It's like stair. Oh, stairs. THD 12%. It's like triangle. Stair step. Oh, next stair. Exponent. Oh, this will be high. Doesn't even measure. It's ugly. What is this? That's negative. Logarithmic. Yeah. THD 90%. That's ugly. So this multimeter has the oscilloscope functionality, and if you need, you can also measure THD for both frequency and both RMS value with quite high precision, comparable to classic analyzers you can buy for like 10 times the money. You can also start data logging, you can save screenshot, save measured value, you can do anything with it. And this app also supports generating reports. Data, I don't have any data, but it can generate reports to PDF, so you can share it quickly with your colleagues or anyone. Well, now if the Hioki has confirmed we have high THD in mains, like 4% voltage THD or so, we must do something with it. If we have, for example, huge variable frequency drive or huge switching power supply, we can place a choke before it. This is usually done when there is enough money for the project, but some VFDs sometimes run without chokes and the network is then all ugly. Common mode chokes with class X capacitors are also used in better power supplies like Meanwell or Delta and such. So, but we can even add external one to our noisy Chinese supply from AliExpress. I personally like these modules. They can be also bought from AliExpress. So the problem and the solution at the same site. And the link is down below this video. I also salvage these chokes and caps and other useful parts from anything that goes to the trash. The chokes particularly are quite expensive, so I recommend salvaging them all the time. In cases where we can't filter the source of the THD, we must at least filter the sensitive device. Just like in my case, my UPS was triggering because of hairdryer, but I won't be placing something like this in the bathroom. So I put something like this before my UPS, and the problem was like 90% solved. Similar case are power factor correction cabinets. For high THD factories we use chokes before capacitors, and sometimes we even use ultra heavy duty caps that can withstand some torture. This combination usually practically makes LC filter with frequency of 189 Hz, I believe. So it doesn't affect the mains 50 Hz sine at all, but it affects the higher harmonics, beginning from third harmonic, so on. So, to sum it up, I hope you understood the absolute base of FFT. So now you know some ground basics, really ground basics, how AC circuitry works. Therefore, I hope you understand the principle of evaluating THD. Why does it cause problems? To mainly capacitive loads, but also network sensitive devices. You also know what multimeter can be used to quickly determine THD in the field, and if you happen to encounter high THD values, you can order a measurement from external company, and you know where exactly should they put the data logger, so you don't place it just blindly almost anywhere, costing you a huge amount of money. And if the THD is confirmed to be dangerously high, you know how to fight it with chokes or these modules when it comes to small devices. So this is all for this video. Goodbye, and I hope I have helped you with this video, and see you in another video.